मैट्रिक्स के इस पार्ट 3 में आज हम कर रहे हैं एक्सरसाइज नंबर 3.2 के कुछ मोस्ट इंपॉर्टेंट क्वेश्चंस, जिनमें हमको मल्टीप्लिकेशन काम में लेना है, 11th क्लास के कुछ ट्रिग्नोमेट्री के फॉर्मूले काम में लेने हैं। तो ऐसा एक क्वेश्चन है सम नंबर 13 पेज 82 पर। क्या दिया है, fx इक्वल्स टू एक मैट्रिक्स है 3/3 की, और आपको प्रूव करना है, शो करना है fx इंटू fy इक्वल टू fx प्लस वाई। fx आपको पता है, अगर fx पता है तो fy निकालना है। वेरिएबल चेंज हो गया, क्या हो जाएगा, जहां पर भी x था वो किस में चेंज हो गया, y में। इसका मतलब हमको fx मैट्रिक्स भी पता है और अब fy मैट्रिक्स भी पता है। अब हमको क्या चाहिए, fx इंटू fy, यानी इन दोनों मैट्रिक्स को मल्टीप्लाई करना है। कल हम मल्टीप्लाई का रूल पढ़ ही चुके हैं। क्या करना पड़ेगा, इस मैट्रिक्स को उतनी बार लिखना पड़ेगा जितने इसमें कॉलम हैं। कितने कॉलम है, 3। दैट्स व्हाई वी हैव टू राइट दिस मैट्रिक्स 3 टाइम्स विथ प्रॉपर स्पेस। सो फर्स्ट वी स्टार्ट विथ राइटिंग cos x sin x 0 sin x cos x 0 0 0 1. This is first time. Now second time, same, cos x minus sin x 0 sin x cos x 0 0 0 1. This is second time. Since there are 3 columns, we have to write one more time. So one more time, cos x minus sin x 0 sin x cos x 0 0 0 1. So first matrix हमने 3 बार लिख ली. Now the first number is cos y. So multiply by cos y cos y cos y, down sin y sin y sin y, down 0 0 1. So this one block completed. Now next is minus sin y minus sin y minus sin y minus sin y. Next cos y cos y cos y. Next 0 0 0. Next 0 0 0. Next again 0 0 0. Next 1 1 1. So this will be the product. Tower number 1 add, tower number 2 add, and tower number 3 add. So this complete society 3 towers, and if we add, see what we are getting. First we are getting cos x plus y, 11th class formula. Cos a cos b minus sin a sin b is a formula of cos x plus y. Similarly the second, sin x plus y. Third 0. Fourth minus common, sin x plus y, minus common, sin x plus y. Third cos x plus y formula. Fourth 0. Fifth 0 0 and only 1. Why all these 0? See, cos a cos b minus sin a sin b cos x plus y, and complete trigonometry class 11th addition formula of sin x plus y and cos x plus y. So this x is completely shifted to x plus y x plus y x plus y. When here it is x, the function is fx. So when here it is x plus y, this is nothing but fx plus y. Hence prove what we want to show, fx into fy equals to fx plus y. So hence prove. So this is question number 13, page 82. Important question, because the function of trigonometry, then matrices, and then multiplication. That's why is a good question. Now we come to the next sum, sum number 15. 15th sum, where we have to write A matrix A is given, a 3 by 3 matrix is given 2 0 1 2 1 3 1 minus 1 0, and we want to calculate the value of A square minus 5A plus 6I. A square. In the previous part 2 matrix, we have already completed how to calculate A square. A square means the same matrix 3 by 3 multiplied by again A square matrix. 5A, scalar multiplication, means each element of this matrix A multiplied by minus 5. So this will become minus 5A. The important point is here 6I. What we write for 6I? It is a order 3 by 3 matrix. So A square is again 3 by 3 matrix. 5A is again 3 by 3 matrix. So how we had 6I? It means this is not 6I, it is actually 6I3. And what is 6I3? You know, 6I3 is nothing but a scalar matrix. When a unit matrix multiplied by 6, each unity 1 1 1 now converted to 6. That's why the meaning of 6I3 is this much. So very easily now you can add A square you have to calculate, minus 5A you have to calculate, and 6I3 the value is here. Simply whatever we want, calculate it, substitute the values and get the answer. The similar one more question is here. Sum number 16th and sum number 17th based on the same idea. So don't worry about the I, how we had 6I. 6I means if it is order 2 matrix, then here you have to write 6I2. Important point. Whatever be the order of A square or A, the same order we have to write here. Even I is not there. Sometimes they write only 6. We can't add 6. It means 6 is not here. It is 6I3 is here. By the way, it is 8. It means it is 8I. So these type of 3-4 questions are very important, especially for the CBSE board exams. Now the last question. So I think you can complete this question very easily. Now we come to the last question, sum number 18th, exercise number 3.2. Very important question, because here we have to use complete trigonometry of class 11th. Matrix A is given 0, minus tan alpha by 2, tan alpha by 2 and 0. I is the identity matrix of order 2, that is I2, and I2 you know very well, this is I2. We have to prove I plus A equals to I minus A into a matrix cos alpha, sin alpha, sin alpha, cos alpha. I means I2, A means given thing. So we can calculate LHS very easily. What is LHS? We write here LHS. I plus A, 1 plus 0, 1, 0 plus minus tan alpha by 2, 0 plus tan alpha by 2 and 1 plus 0, 1. This is the value of left hand side. If we solve separately, we can write LHS is this much. Now what about RHS? RHS we need I minus A first. So 1 minus 0, 1, 0 minus tan alpha by 2, 0 minus tan alpha by 2 and 1 minus 0, 1. This is the value of I minus A. Check it once again. I minus A, 1 minus 0, 1, 0 minus plus, 0 minus minus and 1 minus 0, 1. So is the value of, here we write RHS because we have started RHS. We have to multiply this I minus A with cos alpha. Cos alpha, but we have this side only tan alpha by 2. So this cos alpha, the important point we have to convert in tan alpha by 2. And you know the formula of cos alpha from class 11th. We can write 1 minus tan square alpha by 2, 1 plus tan square alpha by 2. 1 minus tan square alpha by 2, 1 plus tan square alpha by 2. Sin alpha, 2 tan alpha by 2, 1 plus tan square alpha by 2. I think you know very well. Now, sin alpha, 2 tan alpha by 2 divided by 1 plus tan square alpha by 2. So now our complete question in terms of only tan alpha by 2. Everywhere we have only tan alpha by 2. But to write tan alpha by 2 every time, is it difficult? You can. But I want to make it easier. So we can substitute let tan alpha by 2 as t. So now the question is 1 t minus t 1 is the first matrix. Second matrix in the same form 1 minus t square 1 plus t square minus 2t 1 plus t square 2t 1 plus t square and 1 minus t square 1 plus t square. Multiplication you know very well. What is the shortcut? You have to write this first matrix 2 times. Why? Because we have 2 columns. Most important point, if 1 plus tan square alpha, 1 plus t square, 1 plus t square, 1 plus t square is common in the denominator, we can take it out so that the complete calculation may be easier. So 1 plus tan square, 1 plus t square in denominator we are taking out. So what is this? 1 upon 1 plus t square common. Now the question is very simple. Multiply by 1 minus t square, 2t minus 2t and 1 minus t square. Now you have to multiply these two in the same manner what we have completed in the previous exercise. So here the multiplication, we are writing 1 t minus t 1 first time, 1 t minus t and 1 second time. Multiply by first 1 minus t square, 1 minus t square, second 2t, third minus 2t, fourth 1 minus t square, one complete tower you have to add, another tower you have to add, and outside we have denominator 1 upon 1 plus t square. I think multiplication is very easy now. 1 plus t square denominator and here 2t square and 1 minus t square, simple algebra, 1 plus t square minus t plus t cube and plus 2t minus 2t plus t minus t cube and the last minus minus plus 2t square plus 1 minus t square. Now if we simplify, see what we are getting. 1 upon 1 plus t square already out, 1 plus t square here. This is t minus and here 2t. So it is nothing but only t. So we can take t out. It will become t square plus only 1. Here again minus 2t and t, minus t out. Minus t out means 1 and minus t out means t square. Correct? 2t square and t square. So only 1 plus t square. Again 1 plus t square common in all these 4 elements. So if we take 1 plus t square common and 1 plus t square common, here it is 1 t minus t and 1. These two cancel out. What we are getting? See, very simple. This is the solution of RHS. And what we want to prove, see, 1 minus t, t and 1. See, 1 minus t, t and 1, very important. And is not a simple question. Why? Because tan alpha by 2, class 11th formula of cos alpha in terms of tan alpha by 2, sin alpha formula again in terms of tan alpha by 2, and you have to simplify. Patience. In this question we want patience. How to solve a lengthy question, calculation, and you can complete it very easily. So I think now 3.2 exercise completed and you can finish all the remaining questions easily. And next lecture is on matrix transpose, already completed. So finally we have to complete only miscellaneous exercise. So try before that all the miscellaneous questions so that we can complete matrix chapter easily. Goodbye, take care.